Okay, so today we're going to be going over the line of best fit. Content objective is students will be able to determine the equation for the line of best fit for a bivariate set of data. Our language objective is students will be able to read plots and decipher the data. And last but not least, why am I learning this? Well, it's important for real-world problems like analyzing data about endangered species. So quickly, we're going to go over some new vocabulary. The first one's going to be bivariate data. You might have recognized this word from our content objective. So a bivariate data is basically data for two variables, and you can kind of break up the word. Bi means two, variate, you kind of think of variable. So again, it's data for two variables. Usually the data is related. Okay, so here we're looking at a bivariate data where we're comparing the year with the sales of some sport utility vehicles in the United States. Okay, so the other vocabulary word is a scatter plot. A scatter plot is a coordinate graph of bivariate data points. So real quick, bivariate data again is data for two variables. So basically a scatter plot is going to illustrate the data into a graph. So if I take that data and I put it in a graph, here would be a scatter plot. Okay, so now taking a look at this scatter plot, I can see that the trend appears to be linear. So when I say linear, it means it takes the shape of a line that's straight. Is it exactly straight? No, but I can describe it as being linear because I can see that it has the trend of going in a certain direction. Okay, I can also see that the trend is increasing. Why? Because from left to right, I see it going up. So you can think of an uphill line. So I notice as the years go by, so as the years increase, what happens? Okay, as the years increase, I notice that the sales also increased as well. So I would call this a positive association, and you can tie this along with slope. Notice the slope of this line would be positive because I'm reading it from left to right. So you can kind of tie that in with the association of it. So this could help us predict the sales in 2001, in fact. So notice we can get an idea where this is going. So if I asked you where would the sales be in 2001, you can make a prediction based off the data you're given. Okay, so we're going to take a look at some of the different associations of these scatter plots. So again, scatter plots are basically graphs of bivariate data. Bivariate data is basically two variables. So here, notice it's going up, and in this scatter plot, it's also going upwards as you go from left to right. So basically, as the input increases, so does the output. So in other words, as the x's increase, so did the y's. So you can think of this as an uphill, which should remind you of a positive slope. So guess what? These are both called positive association. Here, okay, definitely positive association, but notice here, since they're more condensed near this line, I would call it a strong positive linear association in comparison especially. Now if you look at this, you have two different scatter plots again. So I can still notice that in both they are going downhill. So here, as the x's increased, the y's actually started to decrease. So we can refer to this as a trend that goes downhill from left to right, and we can think of it as a negative slope. So guess what? This is called a negative association. So again, tie it in with what you know about slope. When you read a line from left to right, what is it? Is it negative? Is it positive? Is it zero? Or is it undefined? Okay, so here's a negative linear association. Here, comparison especially, it is a strong negative linear association because the more focused these points are, the stronger the association. The more spread out, not as strong. So here, what are you thinking? Okay, this scatter plot is a nonlinear association. Okay, because the input x appears to have no consistent impact on the output y. So I would say this is no association. Now if you look at this one, okay, this scatter plot, I would say it has a trend. It goes down and then it goes up. So I'm going to say this is a nonlinear association. The input X appears to have no consistent impact on Y. So again, there's no association because I can't see a pattern of what's happening. So this is no association. But look at this one. Okay, for this particular scatter plot, I'm going to notice it's definitely linear, but in fact, it's a perfect linear association because they connect to make a straight line. All points are touching the line. Okay, this one is a perfect linear association as well. However, okay, as the input X values increase, the output Y does not change. So the trend is horizontal from left to right. So hopefully you're thinking this is basically a slope of 0. So I would say this is a 0 association. So once again, if you tie in what you know about slope, you can make that connection. So now let's take a look at a different type of aspect of your scatter plot. Some more vocabulary. There's cluster. Cluster is basically data points that are in close proximity to each other. Okay, so in this particular graph, this right here would be considered the cluster because most of the points are focused within these areas, within this area. Now another vocabulary word is outlier. It's basically data points that stand out from the other. So this is an outlier, this is an outlier, and this is an outlier. So clusters are more condensed into one area, and outliers are not within the clusters. They stand out from the others. So try to remember the difference between the two. Now it says here, sketch the following data and state what type of association. So first of all, I can tell what the association is right away. I'm noticing as I read it from left to right, it definitely has an increasing trend from left to right. So I'm going to call it a positive association. As for a sketch, we're going to be drawing what we call the line of best fit. So it's exactly what it sounds. Basically, we're trying to find a line that best fit these data points. And you're imagining these points act like magnets attracting the line. So you're wanting to try to draw a line that best fits all of these ordered pairs or data points. So first of all, I'm going to recognize that the trend is increasing. So this line that I draw should have a positive slope. Also, it looks linear, so of course I'm going to draw a straight line. Okay, so here I'm going to give you some options, and you're going to tell me whether or not you think it's a good line of best fit. So is this one? Absolutely not. Okay, first of all, it's going down, and we already agreed that it's linear. This one, no. Once again, this has a 0 association, again, because I think of slope. This is a slope of 0. So again, it doesn't follow the fact that it's supposed to be increasing. So this is increasing, however, it's not the best fit. So I'm going to try again. Again, it's also increasing, but I don't feel like it's the best fit for all of these points. Now this here is just right. So notice what I'm going to do is I'm going to go ahead and now pick 2 points. So I'm going to be honest with you. When you're trying to draw in this line of best fit, you want to try your best to have it touch at least 2 of the points, or at least make sure that when you draw it, they fall onto some nice order pairs. Is this always going to happen? Absolutely not. But you want to try your best to do so. That way, when you're trying to find the equation of the line, you can find the slope, because you need at least 2 points to find the slope of a line. So just keep that in mind. Now we're going to go ahead and try some problems. So here, if I have some ordered pairs and you're instructed to find the line of best fit, what's the first thing that you do? Well, first, you're going to have to plot all these points. So I'm going to go ahead and do that. Okay, now what you're going to do is you're going to have to draw a line that best fits these data points. Okay, so now that I have these 2 ordered pairs, what I'm going to do is go ahead and first try to find the equation of the line. Just a quick recap. In a previous lesson, in order to find the equation of a line, we needed the slope and the y-intercept, or you can get two ordered pairs and find the slope from there and use the point slope form to get the y-intercept. So here, just because we're going to practice, I'm actually going to go ahead and use the two ordered pairs to find the slope to get the y-intercept. Some of you can probably already see that where the y-intercept is, but just for good practice, we're going to go ahead and use the two ordered pairs to find slope and then use point slope form to get the y-intercept. Okay, so first things first, I'm going to go ahead and find the slope. Okay, the formula is going to be second y minus first y, second x minus first x, and we always read this as y sub 1 minus, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you know me, I like to draw in these boxes, and the only reason that I do this is so that we don't accidentally lose these negative signs. Some of my students have the habit of, for example, if I were plugging in -1 in for the x sub 1 or y sub 1, they would just put -1 and forget to write minus a -1. So I'm going to go ahead and first write the second y, which is 3, the first y, which is -1, the second x, which is 2, and the first x, which is -2. So again, since this subtraction sign is already there, I don't accidentally lose it. I'm going to be left with, at the opposite, we're going to have 4 over 4. So I would say my slope is 1. So now that I have the slope, I'm going to use point slope form. Hopefully you remember that. It's y minus y sub 1 equals slope times the quantity x minus x sub 1. So I'm going to go ahead and pick one of these ordered pairs. I am going to choose 2, 3, only because they're nice small numbers, but most importantly, they're positive numbers. I would prefer to work with positives over negatives. So I'm going to go ahead and plug in a 3 for y sub 1 and 2 for x sub 1. And of course, my slope was 1, so that is plugged in here. So at this point, this is my point slope form. Now that I know what my point slope form is, I'm going to go ahead and distribute this one to both terms, leaving me with y minus 3 equals x minus 2. Now I have to get rid of this constant by adding 3 to both sides. These will cancel out, leaving me with y equals x plus 1. So here is my slope-intercept form. Because I have my slope, just FYI, it would be a 1 up here. And the y-intercept would occur at positive 1. So now that I have both of these, now that I have my equation, let's take a closer look at what this all means. So first of all, the slope represents the unit rate in context of the problem. So let me give you some context. If I said x is the time in minutes and the y-axis represents distance in feet, okay, what is the slope? The slope is a, first of all, a friendly reminder, there is a 1 technically here. So what's happening? Well, if my slope is 1, my unit rate is also 1, but 1 what? Remember, it's always going to, our ratios are set up as y over x. So this would be 1 foot per minute. Okay, so in other words, this unit rate would mean that the problem is there's an increase of 1 foot per minute. And notice I did say increase because the line from left to right is going uphill. And what about the y-intercept? Well, the y-intercept you can see occurs right here, but we also even proved it with our equation here, that it's 1, which means that's where it started at. Okay, so at 0 minutes, whatever, if this is a person or something, it would mean at 0 minutes, it was already at 1 foot. Cool. So now what if they asked me another question? What if they said, okay, predict how far it will be in 10 minutes. So first thing, what I need to understand is what do x and y represent in my equation? Y represents distance in feet, and x represents the time in minutes. So what they're asking me to do is predict how far. So they want to know the distance. And they're giving me the amount of time, which is 10 minutes. Since 10 minutes is represented with the variable x, what I'm going to do is use my equation to make this prediction. Okay, so I'm going to go ahead and plug in 10 for minutes. So y equals 10 plus 1. So I would say y equals 11. Just a friendly reminder, y does represent the distance in feet. So my answer would be 11 feet. Now something that I also want you to recognize is here, if you were to extend this line through the graph, even though our graph is short, is basically asking us, where do you think it would be at 11? So if you were to extend this line, I think 11 feet would be a reasonable answer. Now, if you somehow manage to put 9 or something like that, you should be able to see, oh, that doesn't make sense because about around 7.8 minutes, that was already 9 feet away. So definitely use your graph to kind of give you an idea of where your numbers should be, but I want you to use your equation to be more exact. So this is good for estimation, but equations are great for using more accurate predictions. Just a friendly reminder, okay? Everyone's line of best fit might be slightly different, should be within the same ballpark. So their answers may vary a little bit in comparison to yours, but overall, again, the answer should be within the same ballpark. So now let's try a second one. Same idea, we're given a table of ordered pairs. First things first, we're gonna go ahead and plot the points on our graph. Then what we're gonna do is try to draw a line of best fit that kind of encompasses all of these data points the best that we can. And again, we're going to try to touch two ordered pairs, or at least get it through a nice intersection so that we can identify the ordered pair pretty nicely. Again, will it always happen? No, but we're going to try our best. So here I'm going to go with this line right here. It does go through two ordered pairs, one here and one here. So I'm going to go ahead and use these two ordered pairs to go ahead and develop the equation of my line. Again, a quick reminder, when this happens, you can definitely use the slope and the y-intercept, okay? Will this always happen? No. Okay, and that's why I'm showing you the other way, which is to use the two ordered pairs to find the slope and then to find the y-intercept as well. But let's be honest, we can see where it touches the y-intercept. Okay, and we can kind of tell what the slope is from these 2 points. But again, this is more of an ideal kind of situation. Will it always happen? No. You want to be able to do these types of problems no matter what the situation. So I'm going to show you how that would be done. We're going to use our two ordered pairs, which was 1, 1 and 4, -5. We're going to go ahead and find the slope using slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in just simple terms, second y minus first y and second x minus first x. Again, you know I like to set it up like this so I don't accidentally lose my negative sign. Second x would be -5, sorry, second y. First y is 1, second x is 4, first x is 1. So here, if you add the opposite, you're going to be left with -6 over 3. So my slope is -2. So now that I know what slope is, which is what we call m, I'm going to go ahead and use point slope form. I actually need to pick one of these ordered pairs. I'm definitely going to go with 1, 1. First of all, the numbers are small and they're both positive, so I like that. I'm going to go ahead and use these ordered pairs and, this ordered pair and slope to plug it into my point slope form. So y sub 1 is replaced with 1, slope of course is replaced with -2, and x sub 1 is replaced with a 1. So this here is my point slope form. Now that I have it, again, this is going to be more useful when you get to high school because this form helps you with identifying the vertex of a graph, but we're not going to be using that in 8th grade. But I still want you to be able to recognize when we have point slope form. So now that I have it, I'm going to go ahead and distribute my -2 to both terms, leaving me with y minus 1 equals -2x plus 2. Now I have to get rid of this constant by adding 1 to both sides, leaving me with y equals -2x plus 3. So here is my equation in slope-intercept form. -2 is my slope, 3 is my y-intercept. Okay, so now that we have our equation, let's take a look at our graph once more in terms of a context. So here's our equation. We do know that slope is basically your unit rate in terms of the context of the problem. So let me give you some context. If I said X represents the amount of time in weeks and Y represents the amount of money, what would this slope mean? Well, our slope is -2, okay? So it would mean, first of all, it is going downhill, so that's negative. So when I'm talking about money and the amount of time in weeks, I'm going to say there's a decrease of how much? Well, $2 every week. Because again, slope is written as y over x, a change in y over the change in x. So here you're writing as -2 over 1 essentially. So there's a decrease of $2 every 1 week. Okay. Now let's talk about the y-intercept. The y-intercept is a +3. We could even see it here on our graph. Okay. The y-intercept basically means that this is our initial value. This is our starting value. So at 0 weeks, whatever, if it's a person or something, it started with $3. So just a friendly reminder, another word for slope is your unit rate. Okay, unit rate is more commonly used with context. And then your y-intercept is your initial value. Okay, initial value again is often used in context. Okay, but slope, unit rate, y-intercept, initial value. Now, given the equation, could you be asked additional questions? Absolutely. This equation is worth nothing if you're not utilizing it for a purpose. So I can ask you something along the lines of, predict at what point will there be a balance of -$17? So first things first, what I'm going to have to do is understand what does y and what does x represent in this equation. Y represents the amount of money, and x represents the amount of time in weeks. So here they're asking us to predict at what point will there be a balance of -$17. I need to figure out -17. What is this? Is this an amount of money or is it the amount of time in weeks? Hopefully you understand it is an amount of money. So in other words, it represents the y value. So what I'm going to do is go ahead and plug in -17 in for y into my equation. So -17 equals -2x plus 3. Now that I went ahead and plugged in my value for y, I can go ahead and solve for x, which is going to basically solve for the amount of time. I'm going to get rid of my constant first, leaving me with -20 equals -2x. I'm going to go ahead and divide off the coefficient. The negatives cancel each other out, leaving me with 10 equals x. But could I just say 10 equals x? Absolutely not, because a lot of people will not understand what that means, especially in context. It did ask at what point will the balance be at -$17. So here, since x represents the amount of time in weeks, I would say at 10 weeks. Now, real quick, we're going to use our graph to just kind of check the validity of our answer. If we were to extend this line up to a point where we can see -17, do you think it would touch at 10? Possibly. It's hard to see, but it's a reasonable answer. Okay, so that's going to conclude our lesson for today. Thank you so much for tuning in, and like always, until next time, bye.